In these notes, we're going to explore exponential functions. First, these two problems that we're going to do, we're going to use our graphing calculator. So I'm going to show you what this graph looks like on Desmos. I'm going to type this function in. You can do this to your graphing calculator or using Desmos.com. When I go to Desmos, here is what my graph looks like. So we are going to identify the domain, the range, the y-intercept, the end behavior, and determine whether this graph is growing or decaying. So first, my y-intercept, it's crossing at 0, 1. So I'll make sure to put that in the paper in our notes. But let's look at what happens when the graph goes to the left. It's going forever to the left, so negative infinity. And as I look on the right, it's going up, okay? But please note that the graph never crosses the x-axis here. So my end behavior, instead of saying that it's going down to negative infinity, it's only approaching the 0 value because it's never going to cross the x-axis. So here's how we are going to write that. Okay, we have the domain. In this case, it did go forever to the left and forever to the right. Our range, it's not going to cross 0, so it's getting very, very close to the x-axis, but it's not going to cross it. Okay, so we're going to use parentheses there instead of brackets because it's not including the 0 value, but it is going up forever. Using the graph, I was able to say that the y-intercept is 0, 1. And your end behavior is always going to start off the same way. As x goes to negative infinity, what does the y value do? As x goes to positive infinity, what does the y value do? And in this case, my y value, as I look to the left, is getting very close to 0, okay? And then on the right-hand side, it's going up. So we're going to say positive infinity for that one. This graph is growing. It is going up. The values, the y values, are getting bigger every time, okay? So take a moment to go ahead and put the next function into your calculator or Desmos or however you graph. Go ahead and put that in and try to fill out the domain, range, y-intercept, and behavior. And is it going down or up? What is happening to your y values as x goes to the right? So as the x values increase, are your y values also increasing or are they decreasing? That's what's going to determine the growth or decay. So when I put this into my calculator, here's what my graph looks like. Okay, I still have a y-intercept of 0, 1, but this time my graph is going the opposite direction. Okay, it starts off at the top on the left side of the graph, but then it goes down towards 0 on the right. So when I go into filling this out, my x values are still going left to infinity and positive to the right. My range, I'm still not crossing that x-axis, so my value is still getting very close to 0 here, but this time the y values start off coming in so higher, but so they're higher on the left. The range, the actual y values though, it's still just 0 to positive infinity, even though it's flipped this time, okay? Y-intercept is the same, 0, positive 1. My end behavior, as x goes to the left, what happens to the y values? As x goes to the right, what happens to the y values? So on the left side, my values are going up this time. On the right side, they're getting very close to 0, but not touching it, okay? So as you look to the right side of the graph, this time, my values are getting smaller. So this is displaying a decay, okay? The values are getting smaller. So let's look at what determines whether it's going to be a growth or a decay and go from there. We have a general function for an exponential, y equals a times b to the x power. The a is going to be my y-intercept, okay? If a is negative, it's going to flip the graph. Okay, if a is negative, it's going to flip the graph. Then we also have B. If B is greater than 1, it is displaying growth. If B is less than 1, it is showing decay. And I'm actually going to write this between 0 and 1, just because if it's negative, then the negative does something else. So we want to keep it absolute value of that. And the last part of my equation here, this x is going to be part of your equation, but if there is a negative exponent, that's going to be the reciprocal of what you think is going to happen. So a negative exponent changes your graph. Okay, so it's going to flip your B value. So if the B value is a number bigger than 1, you originally think it's a growth, but if the exponent is negative, it actually means the opposite. Now it becomes a decay, okay? So looking at the two graphs that we just worked with, the A value is invisible in this case. Technically, there is an A value of 1 in front of it because 1 times 1/2 is the same thing. That's how I get my y-intercept. Same thing over here. This is technically 1 times 2. And again, that's why the y-intercept is 1. So by looking at these equations, we're able to determine whether these are growth or decay, okay? Remember, if it's a fraction less than 1, it's generally a decay unless the exponent is negative. So in this case, I'm looking at the term with the exponent, and this term is a fraction less than 1. So originally I'm thinking, oh, that means decay. However, this negative means the opposite of that. So this is actually a growth. Again, the negative changes that B value that we're talking about. Okay, then here, be careful with the parts of the equation. So the part that is being raised to that x exponent, that's what we want to focus on, not the 5 in front of it, just that fraction. So in this case, this is displaying a decay because that fraction is less than 1. This one here, we have a fraction, 7/4 is greater than 1. So I'm thinking growth, but then I look at the exponent and notice it's a negative, so that changes it to a decay. And lastly, I have a fraction, 9/2 is greater than 1, positive exponent, so this is in fact a growth. Okay, so you will need to identify whether it's a decay or growth from there. All right, so now we're going to jump into more examples where we actually have an A value, so that's going to be the y-intercept. Remember, in the first two examples that we did in our graphing calculator, the A value was just 1. It was invisible in front of it. This time I actually have an A value right there. So if we follow what we just wrote down, where that A value represents the y-intercept, I actually can already put in that the y-intercept is going to be 0, 3, based on that y value there in my equation. Okay, looking at this, you can already determine whether this is going to be a growth or decay. Looking at the term that has that exponent, so that 2 is greater than 1, the exponent is not negative, so this is going to be a growth. So I'm going to sketch my graph here. Okay, it's going to be going up to the right side, and I know that exponentials, they have an asymptote at 0. We haven't really talked about that yet, but generally they're not going to cross the x-axis unless I shift the graph, and we will get there. So my domain is still negative infinity to positive infinity. My range still does not cross 0, so I need to put a parentheses there, but it does go up forever. And then my end behavior, as x goes to the left, my y values are approaching 0. As x goes to the right, my y values are approaching positive infinity. They are going up. So I'm just going to confirm here on my graph that it looks that way. That way we know we are using the equation correctly. So I typed in 3 times 2 to the x on Desmos. There is my y-intercept. There's the general picture of the graph. So we really just need you to sketch it. Okay. Let's go on to the second one then. Using that information, again, this number in front of what's being raised to the power represents your y-intercept. So that's at 0, 5. So I can start by graphing that here. The quantity being raised to the x power, that's going to tell me growth or decay because that is a fraction less than 1 and there is no negative. This is going to be a decay. So generally I can sketch my graph is going to be going down through that y-intercept and then approaching the 0. So my domain is still going from negative infinity to positive infinity. My range still down to 0, not touching 0, going up forever. As x goes to the left this time, though, the left side of this graph is going up, so f of x is approaching positive infinity. As I go to the right side, my y value is getting very close to 0, but it is not crossing 0. So that is what I would put for those. Okay. So up until this point, our graphs have not crossed the x-axis at all. They have been staying above the x-axis. That's going to be a horizontal asymptote for us, okay? So these graphs, though, will shift, and they will acquire a new horizontal asymptote based on whether they're moving up or down. So we're going to start off by looking at this first one. We're going to type this function into our graphing calculator or Desmos, whatever we're using, and we're going to see how the graph is shifting, okay? So let's go ahead and see what that graph looks like. I typed it into Desmos. It's important that you put the exponent in parentheses, otherwise it will not work. It'll move the -1 down. So this graph did cross the x-axis down, but now if you look at the values here, it is getting very, very close to that -4, but it's never going to cross -4. So if you look back into the equation, there is a -4 there, so that's going to be how it's shifted down, and that's going to become your new horizontal asymptote. My y-intercept also shifted down. My x-intercept is different this time. So I am shifting my starting point for this graph. So going back to the notes, okay, this -4 shifted the graph down, okay? So this is shifting the graph down 4. And again, that is going to represent your horizontal asymptote is always y equals, right? So that's going to be my horizontal asymptote. It's going to be down here. It is never going to cross that horizontal asymptote. And then here is how we get our new starting point. So before, I would just look at the 3 and say, oh, my starting point is supposed to be 0, 3. I know that based on the a value in front, right? We looked at that in the previous page. So my starting point is originally supposed to be 0, 3. However, I then apply a translation to it. Now, this is telling me to shift, and this -4 is telling me to shift. So the x -1 is telling me that I'm moving right 1. This is, remember your h and k values. H is always the opposite of what you think. So because it's a -1, that actually means I'm going to move right 1. So my translation, I'm actually going to go +1 and then -4. So again, this means right 1, down 4. When I apply that, I'm going to apply it to my starting point. So really 0 plus 1 would give me my new starting point. 0 plus 1 is 1. And then again, I would go 3 minus the 4 would give me a -1. So really this graph has a new starting point at 1, -1. And then generally we saw it went this way, right? So if I go back to my graph really quick, there is a point at 1, 1. So you can see right there. That's how I'm getting that new point after the translation. So this affects my end behavior a little bit. As I go to the left side of my graph, my y value is now approaching that -4. As I go to the right side of my graph, my y values are just going up. So this graph is displaying exponential growth. And there's a few things that should match here. Your end behavior should be related to the horizontal asymptote somehow, which will be affected by which way you translate it up and down. Okay. Let's go ahead and try example 2. So I'm looking for that starting point, that a value in front of the parentheses. When there's nothing there, there's always going to be an invisible 1. So my starting point in this case would be 0, 1. But now I'm applying these translations to it, where I need to look at the exponent, do the opposite. So this means go left 2. And then this k value is telling me to go up 3. Okay, so really the translation is going left 2, up 3. And I am applying these changes to my starting point. So 0 minus 2 is negative 2. 1 plus 3 is 4. So my new point, I really am starting at negative 2, 4 right there. Okay. My horizontal asymptote is the way I shifted vertically. So this up 3, that means my horizontal asymptote is at positive 3. So I'm going to go up to 3, and I'm going to draw in my horizontal asymptote. This, when I look at my fraction, this fraction means that we have a decay. So it's coming from the left and then approaching. It should be approaching that asymptote a little bit more. Let me try to fix it a little bit. There we go. So that is how I will draw it. So this is based on the fraction. This is going to be a decay, so it's coming down from left to right. My end behavior then is negative infinity. F of x approaches positive infinity. On the left side, we're going up. On the right side, we are approaching our horizontal asymptote. And that is going to be the case every single time. Let's go ahead and try 2 more, and then we're going to write down the general rules for these exponential graphs. In this case, my starting point, again, focusing on that number in the front, it would be 0, negative 3 if there were no translations happening. But when I look here, this is telling me to go right 1, which I know that means I'm going to add 1 here. And this is telling me to go down 4. So I'm going to subtract 4 here. So that would make my new point that I should be graphing 1 and negative 7 if I go ahead and add those together. My horizontal asymptote should always be that k value, the translation going up or down. In this case, that's at y equals negative 4. So I go down here, draw in my asymptote. And if I go ahead and graph my new point at 1, negative 7, I actually end up somewhere down here. Okay? So let's think about whether this is going to be a growth or a decay. The number in front, the one being raised to the power, looks like a growth to me. Okay, so technically, yes, I'm seeing growth, no negative exponent. But we also talked about this negative reflecting my growth. So this is a reflected growth. Therefore, yes, it's still going to be going up exponentially, but it's being reflected, so it's going the opposite direction. So if that negative was not there, I would look more like this, right? Going growth that way, but that negative reflects your growth. So you're taking that growth and reflecting it below that horizontal asymptote. So in this case, my end behavior, as I go to the left, this changes things a little bit. Now I'm going towards negative 4, but as I look at the right side of my graph, now I'm going down. So just be careful. Let me fix that, negative infinity. Be careful if the graph is being reflected. That's going to affect your end behavior. It's still technically a growth, but it is reflected because of that negative. Okay. All right, last one here. And then you're going to have a lot of practice. So my starting point should be at 0, and then there's technically, remember that invisible 1, this time it's negative. So again, this negative is reflecting my either growth or decay, whatever that is. My translation here, I'm going left 2, so that's a minus 2, and up 3, so that's a plus 3. That plus 3 is also my horizontal asymptote, so I'm going to go ahead and add that now, which makes my new point negative 2, positive 2. So I'm going to go to negative 2, positive 2 right there. When I look at the actual equation, this fraction is telling me that this is going to be a decay. But then again, there's that negative, which means this is going to be a reflected decay. Okay, so normally my decay would come this way, but this time because it's reflected, it's going to look this way. So I'm going to erase what it could have been. That reflection does affect the rest of my answer. So now the left side of my graph is going down to negative infinity, and the right side of my graph is approaching that horizontal asymptote of 3. So a lot going on. You have to look at whether it's greater than 1, smaller than 1, whether it has a negative in the exponent. That's going to change the growth or decay. But if the negative is in front of your A term, then it's going to reflect your growth or decay. So let's go ahead and put all this together. How are these translated graphs all coming together? There's a lot of moving pieces. So generally, the equation is going to be y equals a times b, x minus h, and then plus k off to the side. So again, this a is going to be your starting point. Okay. If a is negative, then it's going to reflect your growth or decay. Then we have B. B tells you whether you have growth or decay. So remember, growth if B is greater than 1, and we have decay if we're between 0 and 1. Then new parts here, we have our H value. Our H value moves the graph left or right. And just like it's been in the past, it's always the opposite sign. So if it's a negative, I'm actually moving to the right. If it's a positive, I'm moving to the left. K tells me to move up or down. And it's also the horizontal asymptote. Okay, so it's going to have 2 parts to it. And remember, last little side note here is that your H and K is going to move your starting point. So we're going to have you write down the starting point, but then you're going to show how it's moving it. Okay? All right, so let's go to the next page and just practice all of this. So the idea here is that you're trying these problems without using your graphing calculator. It would help if you start by identifying, is this going to be a growth or a decay, and then go from there. So this very first one, we have, looking at this number, we're going to have a growth because it's greater than 1. We're not being translated left or right based on the exponent, but we are moving up 1, it looks like. So remember, your starting point is that number in front of the parentheses being erased. So my starting point is 0, 1. But actually, my new starting point is now going to be 0, 2 because I went ahead and I added 1 to my starting point because I am being shifted with that k value. So my new starting point is at 0, 2 here. I have the horizontal asymptote at positive 1. Remember, that comes from the k value. So I have a horizontal asymptote there. And because this is going to be a growth based on that 4 to the x power, I'm going to be going up to the right. So I'm going to circle growth, and then I can write my end behavior. As x goes to negative infinity, my y values are approaching my horizontal asymptote of 1. As I go to the right, my y values are approaching positive infinity. Okay. Go ahead and pause the video now, see if you can figure out how to do number 2. Hopefully you went ahead and tried it. Again, it might help if you identify this is going to be a decay, and then this is being shifted right to down 1. The down 1 is going to give me that, or up 1, sorry, that horizontal asymptote, so positive 1. Starting point is originally 0, 1 because there's an invisible 1 there. But then after I add 2 and add 1 here based on that translation. The h value, right 2, and then up 1, right? Then my new point is actually at 2, 2. So I go to 2, 2. I put in my horizontal asymptote. This is going to be a decay, so it's going to come down this way. And my end behavior, as x goes to the left, my y values are going up. As x goes to the right, my y values are approaching that horizontal asymptote of 1. Okay, go ahead and try. Let's focus on just number 3 right now. Pause here, try it, and then we'll come back with the answers. Here is the answer I should have gotten for number 3. So again, that starting point, we're focusing on the number in front. That happens to be a 2. But then I'm shifting the graph -4, -1 based on the h and k, which means my new starting point is at -4, 1, with my horizontal asymptote being at that k value of -1. It is a growth, and then that is my end behavior. Going on to number 4, my starting point this time is at 0, -1. Remember, negative and then the 1 there. My horizontal asymptote is going to be based on the k value, in this case, -3. I'm going to apply the h, -1 opposite sign, and then -3 for that one. So my new point is at -1, -4. So I'm going to go ahead and plot that there. My horizontal asymptote is at -3. Okay, and here is the fun one that we were talking about. So this is going to be a decay, technically, but it is a reflected. So although we generally think of decays going this way, it's going to be reflected, so it should look more like this. Okay, so that makes sense because it shouldn't cross my asymptote, so the graph needs to be going this way and then approaching my asymptote that way. So for my end behavior, as x goes to -infinity, f of x is going down to -infinity. But as I look to the right side of my graph, I am approaching my horizontal asymptote of -3. All right. So with that, just being careful with the negatives, pause one more time, and then I will show you the answers for 5 and 6. All right, here are the answers for 5 and 6. So looking at 5, we have our horizontal asymptote at 3 based on that k value. We shifted the starting point right 1, up 3. And because our starting point was originally at 0, -1, that puts us at 1, 2. So then there is a negative in front of that 2 there, which means it's going to reflect my growth, okay? So that's why I circled the growth there. Then for number 6, we see a fraction. So that means decay. It is the h value is +3, k value is 4. So I shifted my point, and now my new point is at 3, 5. Horizontal asymptote is at +4. There is my graph and my end behavior. So that is the end of these notes. Let us know if you have any questions, and thanks for watching.